Hi, my name is Katina Michael. I'm the coordinator and instructor of Co-Designing the Future in the new Public Interest Technology degree. And today I'm fortunate to be having an interview with someone I've met in the last 2 years. His name is Mike Stanley. And amazingly, get this, students, he was formerly with NXP Semiconductors for just over 39 years. So I thought, how am I going to give you something with that gravitas that you deserve? I know a lot of you are in senior roles, and it is Mike, among several others I've invited. So welcome, Mike Stanley.
Thank you, Katina.
Um, Now, Mike, I know you're an affiliate with the Sensor Group
Yeah.
in the engineering school, electrical engineering, with Andreas Banyas, and Andreas was kind enough to introduce us. And I'm really curious, first of all, where did you start out? I know you're a local to Arizona. Uh, where did you start out in industry and what got you there?
Okay. Well, actually, I grew up in the Midwest. I got my bachelor's degree at Michigan State University in 1980. And at that time, I interviewed with Motorola Semiconductor, among others. And Motorola Semiconductor was located out here in the Phoenix area. And they were the primary employer in the area. And I liked the people. I came out and I joined them, and I've been here ever since. Eventually fell in love with Phoenix, and I continued to enjoy the people I was working with right up to the time I retired, eventually from NXP. I should mention Motorola Semiconductor spun off Freescale Semiconductor, which was then merged with NXP Semiconductor, and that's where it was at when I finally retired. But from my perspective, it was the same desk the whole time. Essentially, I just moved, maybe from one office to the next, but same employer.
And how would you describe your work in level of technical involvement and engagement? Was it highly technical? Were you a technical specialist? Where did you start out in your sort of job skill set and positions?
Good question. I've always regarded myself as a technologist. So when I came out and I joined the company, I went on to their engineering training program, which gives you the opportunity to try different disciplines for a period of say 3 months each. And you'll try one after another, after another. And after a year, you placed into a specific area. Well, I did that, and I placed into an analog design team. And I did bipolar analog design for 4 or 5 years. And at that point, we were forming a new business group, which was called the ASIC organization. And I moved over there and started doing computer-aided design work. So I was designing simulation libraries and CAD development tools. That segued 4 or 5 years later into actually doing design work for SoCs, systems on chips. I did design work there. Eventually, I became a design manager doing SoCs, specifically with digital signal controllers, or DSCs, as well as with MCUs, or microcontroller units. So I worked both as a design manager, and eventually I actually backed out of management, and I moved back into a technical role, strictly doing architectural work, which I really enjoyed. Eventually from there, I leveraged that, and I moved into a sensors organization doing systems design, so high-level applications, sensor fusion and machine learning. And then from that, I moved into a systems role my last couple of years, where we were actually working on products which could go in as system or subsystems into a larger system. So there'd be a small PCB, there would be software running on that PCB, and everything that goes along with it with regard to getting FCC certifications and those types of things. So really, I worked the entire food chain in terms of everything from transistors all the way up to the full systems. And I've also, as I said, focused primarily as a technologist. That's where my heart's at, but also had that experience multiple times leading teams and understanding some of the issues there.
What's amazing is the scale at which you worked at, and this micro scale with chips and chipsets and systems on chips.
I actually started out drawing transistors for my first few designs. We would hand draw our transistors.
And some of our students might find that really odd because of their age, but one of my first opportunities in industry after Apple uh, was to gain exposure at Otis Elevator Company, and I met the draftsmen and women who had these massive desks and were just like drawing these intricate like structures, right? And I'd look and I'd say, how is it changing? Oh well, CAD's changing everything. And next year, this was mind you, 1994 in Australia, and in 1995, Otis brought in the CAD systems, right? And it changed everything. How
That
people sat, what they did when they went to work. They were no longer holding this pen or pencil. Um, and CAD gave so much to the draftspeople. That's how they used to describe themselves. It gave them the ability to go faster and redesign faster, um, to go at scale, to zoom in a way that they had never done before. But did you see that same transition?
Absolutely. As I said, when we initially started, I would draw the transistors by hand, and we would have a technician who would take those drawings and they would then digitize them on the system that they were working on. I'd gotten there just after they stopped drawing these things on something they call Ruby, which was essentially plastic that they drew on. But when I first started, we had a couple small rooms with 3 computer terminals each for a large department. So you actually had to go into the room to access the computer. So, when we finally started getting CAD systems in-house and available to the individual engineer, it was really a major transition. The other thing that really I welcomed was the fact that we started getting tools that could check those designs, that could run physical layout checks. And I can tell you, as a young engineer, designing my own circuits and then overseeing the technician laying them out, I would be out there with a ruler checking every single measurement on these layouts. We used to have something called beer checks. You would invite your coworkers to come, and if they found an error in your layout, you bought them a beer after work. And it's a very stressful time because at that time, if you had an error in your layout, well, the cost of a mask set was essentially half a year's worth pay. We took it very, very seriously. And really, that never changed because the mask sets just got more expensive over time. So even though we made more money over time, so did the mask sets. And also there's the delay factor, the fact that, once you tape out, it's an additional, say, 10 to 12 weeks minimum before you actually see your first prototype. So in terms of time to market, all of that is very precious time. You can't afford mistakes. And that's, you and I were talking before we started here this evening. It's something that continues to run very strongly through the industry is time to market. So there's a strong emphasis on getting those designs right the first time so they don't have to iterate on them.
I want to give you a backdrop now about what we're studying in 502, a term and a methodology and a mindset called co-design. And co-design, a bit different to design itself in our traditional life cycle in the engineering field and technology field, um, looks at how we design with people or with users rather than for them. It's a total flipping of the mindset, although you might actually tell us otherwise in a moment. But it's usually about large scale systemic change in communities mainly. For example, it tackles problems like homelessness, or it tackles problems like how do we deal with mental health issues in society that are increasing, issues to do with uh, access to health services or education or racism, how to overcome that in cultural settings. So we're sort of using co-design as a mechanism to almost go through these various steps, of which I've outlined 7 or 8 in our curriculum,
Mm-hmm.
including like where do we start with the original problem, how do we define it, how do we engage the users, um, whom our system or the process will affect, how do we learn from them and discover and see what their pain points are, how do we move on, and design something in response to these interviews or focus groups or surveys we conduct. And then finally, how do we take something to market as a concept, engage people, allow them to embrace what they've co-developed and co-created, and then sort of systemically allow them to be empowered by that change. But one reason I've reached out to you is because you know this process within the technical field. And I'm wondering, in our first sort of point, whether you could talk us through what you were used to going from in a design of a new product. Or where would it begin and where would it end? What would you see in your technical role?
Okay, it's a good question, and this evolved over the course of my career, very much so. It was very informal in the early days, very formal in the latter days. So currently, most of the employers that I talk to, they have a very formalized process. And by the way, just before I start that, I'll mention, to me, co-design was something different. We used to think of co-design as designing hardware and software together. And that was a big improvement in the way things were done back in the 90s. You're taking it a step farther, and you're pulling in, the cultural aspects of it, so the societal aspects.
I
But
love
I
that story.
digress.
I love that story.
So anyway, in terms of how we would start a design, typically you've got a team that has a certain set of technologies available to them. And they're going to start looking to see where can they leverage those technologies in the marketplace, or where can they develop new technologies. So somebody will throw out an idea for a product. And the first step in the process is to get together with your marketing team and find out if that product is a reasonable concept. Is anybody going to even buy it? You might have the best design in the world, but if it's not of interest to people and if it's not economical, they're not going to buy it. And that will involve multiple teams. It will involve a marketing team primarily, but it will also involve the design team because we'll be doing feasibility analysis. A number of times in the past, I've seen some of these teams get together and actually go out on the road and visit multiple customers, maybe 2 or 3 customers a day over the course of a week. So, there were multiple times when I would go to Europe, for instance, and we would be going from country to country, new country every day, trying these ideas out with the customers and getting their feedback to find out, does this stick or do we need to adjust the concept? And sometimes we would adjust the concept. Then we would come back, we would continue that feasibility study, and at some point you have something we call a phase gate, where management says, yes, we think it's time to go on to the next stage in the process. That's the point at which, as a system designer, I would get involved in terms of starting to write up the preliminary specifications for that product. So you start out with a high-level data sheet, very preliminary data sheet that you can show to people. Say, is this still looking good to you? Is this what you're after? Eventually, there's going to be another phase gate. Then we're going to get into detailed design. And in the teams I was working with, when I was doing the architectural design, I would actually write a detailed specification for all of the hardware in the product. And that specification would be complete down to the register level and might be 500-600 pages. Now, today, on more recent ones I've seen, those reference manuals can easily be over 1,000 to 1,800 pages. So they're very, very detailed. And we would look at both the hardware and the software aspects. What's necessary to bring this product to market? At that point, you're once again going in and you're trying to do cost estimates. What's it going to cost us to create this? And here I'm talking about man weeks. How many engineers of each type of engineer is it going to take? Do I have those resources available? Am I competing with other projects for those resources? Typically, I am. Nowadays, you'll find that oftentimes these teams are scattered across multiple continents, because you'll find maybe there are going to be more senior, high-priced engineers in one area, like me, doing that high-level definition, and maybe I would have a design team that was in a lower cost engineering area actually doing the detailed implementation. At the same time, we would have a design and test team working on developing the test programs for this. Now, once we got that detailed spec put in place, again, another phase gate. You review it, you make sure that everybody buys off on that. Then the design team's really jumping on it. They're actually implementing it. Your DFT or design for test people are adding features into the silicon to make it easier to test. They're working on test programs which are being run in a simulated environment. So as we build up a computer model for this new device, at the same time we're running software on it. So by the time that we actually get to what we call tape out, we know that that product is going to work. We've already run, probably hundreds of thousands of lines of code on it, testing out each of the individual parts of that system on chip. And we've also, as we've gotten to that point where we're confident with the design, at some point we'll freeze that design, and then the layout people are getting serious in terms of laying the design out in terms of how the various physical patterns for these transistors and gates are arranged on the die, and running the various software on there to do parasitic extraction to improve our simulations so that they're time accurate. So at that point, we're running static timing analysis to make sure that the timing of all of these components is actually going to work. And again, that all relates back to the test program, which is going to be run on that first silicon when it comes out 10 weeks down the road after we finally tape out. And as we mentioned, earlier when we were talking, when that first silicon arrives, ideally, we should have all the hardware necessary to put those wafers on a tester, lower a set of needles onto the wafer, and test it within the first 24 to 48 hours. That's our goal, is to be able to do that. And we want very quick feedback. If there's a problem, we want to dig into that problem as soon as possible. If there's not a problem, at that point, we're going to have devices built up into packages, and then we're going to start doing detailed evaluations in the lab to look at things from an electrical perspective. And about that time, you also generally have customers who are begging for samples, so you're doing all this stuff in parallel. And then at some point, you've gone through all this process. You've tested it with your production test program. You've done a detailed lab evaluation of your silicon. Your product engineers have gone and looked at it from a reliability perspective, and you had additional phase gates to actually do a product release out to the field. And I've left off all kinds of details because it's quite involved, and there are many pieces of documentation that have to be created at each stage of the game. A lot of, especially if it's a safety critical type of product, your customers are going to demand that you can show that you've used the proper design techniques to ensure that your product meets safety critical criteria. So the documentation is as much of a deliverable as the product is at the end of the day.
Yes, and I mean, I love this end-to-end description, and I know if you're, going through an FDA approval process, for example, in the United States, the documentation is golden. It's the evidence, it's the history file that they're looking for.
And we were audited that, on a regular basis for ISO 9000. You're going to get audited, and you have to be able to prove to your customers that you're certified.
Mm-hmm. I remember going through that process both at Otis Elevator Company, because it was elevators, right? And there were safety issues and so much, I remember the testing facility of the actual elevators and a lot more, but that also was something we attempted within the systems engineering group at Nortel, and were never successful at doing that. They wanted everything, emails, our correspondence, how we got to, on the software side, they achieved that. On the systems engineering, we didn't. Very interesting, that whole process of gaining ISO 9000 certification. There's so much I want to unpack here. I mean, I want us to talk about if we start towards the beginning, our process, I've looked at a generic process for co-design. I think I analysed about 15 different peer-reviewed um, papers and government reports on the processes involved and the steps involved and what you're calling gates. We used to call them gates as well at Nortel.
Yeah, I
And
think
the
it's a standard
phases.
term.
Yeah, I think it's a great term. And I think I'm going to adopt that for the class, actually, as we're going through our project. And everyone will choose different projects. But the whole idea is to be detailed up front. I'm hearing this. You went as detailed as you could at the beginning. You documented everything because
Yes.
that shows the history of it, the evidence of it, where we began, where we've decided to deviate from, where we've tested and failed, we're going.
It's also risk management. I think you may recall when we first got together over a couple drinks a year back, we talked about a project I'd done where I worked on a project for a safety critical SoC doing the architecture to make sure that architecturally I could guarantee that was a safe product. And after 6 months and many hundreds of pages of documentation, I concluded, yes, I had a safe product, but I couldn't make it in a commercially feasible approach. And my recommendation was to cancel the project, and we did. So,
Okay,
so managing our risk by canceling early is part of the process.
so we have a study called the Feasibility Study,
Mhm.
which takes place not after the requirements analysis, but before. And I wanted to ask you, where is the best place in the sequence to put a feasibility study? It's early on, I would gather, because of this commercial aspect, the economic feasibility. There are
Yeah.
other types of feasibility we're going to cover in the class, but where would you say, is it after the problem definition stage, after a few proof of concepts? Where would you say is the optimal place to put a
I
feasibility
would,
study?
we used to have, the first phase, we used to call it concept phase, and we would start doing feasibility analysis immediately. And we would continue that for the first couple phases of the project. So it wasn't something you did once, it was something you did continuously, and you were always looking at it and trying to figure out what were your issues.
You've given me an idea there, which is possibly to break that assignment down into three and to keep revisiting feasibility throughout our early concept definition stages and
Yeah,
needs identification. So that's
yeah.
that's going to
In
be
many
interesting.
cases, those early documents would actually just evolve. So your initial concept document would evolve into your preliminary data sheet or whatever you wanted to show to a user, and then that would evolve into the later details of the design. And it was the same thing with many of these different concepts. The documents grew; they were living documents.
Yes, and this idea of it not being static, right? That there are. I remember us going to .23, like a version 23,
Yep. Yep.
and so on and so on, and that was really important. The version control, how we shared data between teams and between individuals. But let me pick your brains now on something that Nortel used to call the plan of records, which was the plan for that particular concept as it developed into what is a product and the role of the business development manager. I mean, what's interesting to me is that you, as such a technical person, which is wonderful, by the way, was taken. You mentioned the countries you visited. The roadshow. We used to call it the roadshow. Um, to see if it would stick, and how heavily involved at NXP Semiconductors were you on that side of business development? Was it one function, the engineer or the systems engineer also had the function of sort of business development, or you worked in concert and in concert with
There
other
would be a
managers?
separate, typically you'd have a separate marketing organization that would be putting together the business plan. And they would be part of that initial project team, and the systems engineer would be part of that initial project team. They'd work together.
How technical were your marketers?
It varied tremendously. You had some that were very, very highly technical, some that were less so. Uh, in general, most of the people I work with, though, they were pretty good.
So were ours. I learned so much from that team. And I was actually sort of, you know, we were called the systems engineering department, but to be honest, we were pre-sales engineering. We were the get business part of the process, not the do business, although occasionally we tended to do some implementation, but rarely as systems engineering. And what I find interesting is pre-sales and our relationship with marketing was quite, we were very close together. We had to be.
Yeah.
Because we were writing the bid responses to those RFIs, the requests for information and requests for proposals and quotations. Um, and so I find that fascinating. Can you give me some job titles that were involved in that early concept phase? We mentioned the marketing people, we've mentioned in your case systems engineering.
Systems engineering, and design engineering might have multiple subdivisions. So you might, for instance, when I was with our sensors division, you would have one set of design engineers that were doing circuits. So they would be designing what we call the ASIC, which integrates all the components. You would have another set of engineers that were working on the MEMS components, and MEMS stands for micro mechanical engineering, tiny machines. Let's just say tiny machines. It's a different type of designer. And then you would have package engineers, and they would all have to be involved. And it's interesting, especially with sensor type of products, the package had a very big impact on the performance of the device. And coming to sensors from an MCU background like I did, I used to think of a package as just being a different set of pinouts. And when I got into the sensors organization, all of a sudden it's affecting the performance of the product. And I'll give you, I'm digressing a little bit, but as an example, we once found that labeling a part with a lead pencil changed the performance of the device electrically from the lead on the pencil. We were getting different results, and until we actually erased the label and got back to the original, it took us a while to figure that out. So anyway, going back, yes, you have to have all of these different people involved, because if you're doing anything new, and typically you are, every product has got some aspect of it that's new, and that's what you're going to be focusing on. That's where your highest risk is going to be at. So they're going to be involved from very early on. Marketing is going to be doing a lot of the, as I say, looking at customers and whatnot, and then also finance. We didn't talk about them. And then also you're going to have managers from product engineering that are going to be sitting in on it. So product engineering and test. And then typically, at least in this business, even your division manager is going to be sitting in on meetings from time to time, because they might have half a dozen projects going at a time. They're not having hundreds of projects going at a time, because these things are enormously expensive to build. They take a big expenditure of engineering talent and time and money. So everybody gets involved at some point, generally pretty early.
Yes, I remember similar roles. We had account teams looking after the customers. We had,
Yep.
in our case, a wireless country manager, or broadband or mobile, whoever it was, given my business was in telecommunications. But yes, we had the finance people sometimes pull the plug. I do remember a time just past the dot-com crash period where we used the Pareto principle and decided after buying so many companies out. I think at one stage we were buying, like in 1999 and 2000, we must have bought 32 companies in 6 months.
Oh.
It was a lot, which meant that we had redundancy in our product range. We had employees that had never worked together, had different systems, had different gate processes, and we had too much. So what they decided is post.com crash, as share prices began to dive and affect the actual product development process because of finances, that we said, okay, we're going to focus on that top 20% tier customer
Yes.
range and forget about the smaller fry, because we don't have the capacity anymore and we just need to get some big contracts. So the finance guys and girls used to pull the plug, on the commercial side very early. And I remember those account calls were really heavy because you've got internally people vying for different things. A lot of the tech guys were thinking commissions, and let's do this. It's good. And then the accounts team looking at it, going, "This is not going to fly." But there was a little bit of conflict and jostling early on.
We had the same kind of thing, trying to apply the 80-20 rule to our customer base. And the way the big semiconductor houses typically do it is they have distributors associated with the manufacturer. So in each region, we would have, typically at least 2 or 3 distributors that would be handling the 80% of the customers. And then we would be dealing directly with the 20% of the customers who were actually the bulk of our business. And so we would split up the support. We would be supporting some customers directly, others via the distributors, and then we would be supporting the distributors. And I would be involved in that as well, and from a product support perspective.
Yeah, all very familiar. I remember even, Mike, we would charge as a cost of sales the engagement when it got a little bit tenuous post.com, because these were big resources. We're talking about a lot of time invested, as you're saying, and a lot of people coming together. You mentioned people working virtually. Give us an example of how the virtual teams, how spread out were they that you worked with?
I would say when I first started working a lot with virtual teams would be in the late 90s. And that was when the company first started looking at taking advantage of places like India, for instance, for low-cost engineering. And in our case, we actually went out and Motorola at the time bought a small design house in India. And that was one of my jobs back in the late 90s, was to go over and meet that team and pull them into our design process. So, I made multiple trips over to India to meet the team. We would bring engineers over to live with us for 2 or 3 months at a time, and actually train them on our processes. So they got to know us very well. We got to know them very well. Typically, there would be calls at least a couple times a week. Now, this was before Zoom, before we could chat like this. But we would be on a phone call and we'd be talking. And by the way, just as kind of some side points, one thing I learned with that is it's very helpful to actually go and meet your team, because I did not know until I actually went to India then of some of the constraints they were working under. So for instance, we often had a hard time understanding them in some of the calls. Well, when I got over there, I discovered they had a very small room with a very poor speakerphone and a loud fan overhead. Well, of course, we were going to have a hard time understanding each other. So then we could start to address some of those structural fundamental issues, get them taken care of, and try to streamline the approach. Now, over time, what I found was the teams got even more and more geographically distributed. So by the time I left, it was not unusual for the team that I belonged to, which was a systems engineering team at the time. We had people in China, we had people in Korea, we had people in France, we had people in the Czech Republic and Romania, all working for the same manager. We all had the same next level manager. So the teams got very, very distributed that way. You just learn to live with it. Now, since COVID is started, most people in this business have, at least this part of the business, they haven't been in their offices for the last 9 months. They're all working from home now. So what we started back then has come to its logical conclusion now during the pandemic. Unless you have a reason that you have to be in the factory, you're not in the factory right now. You're working from home. And even my colleagues who were doing lab evaluations, in many cases, they've got many lab setups in the homes now.
That's all phenomenal. And I do remember being on daily calls. I was situated in Australia, in a small town of 300,000 people. It's bigger than a town. One of Australia's regional centres, about 300,000 people spread over hundreds of kilometres. And time zone was interesting. We would You know, in Australia, we'd wake up first, and the last thing you wanted at 5 p.m. was, an engagement with the Philippines or India or somewhere else, especially India, because it's 5.5 hours behind, which meant that, we'd be at the lab for another 5 hours. But of course, it gave richness to us culturally.
Oh
I
yeah.
didn't expect when I became an engineer in that company that I'd be on the phone daily with people from India, that I'd never met in the flesh, and then I'd get to travel. I never got to India at that time, but I went to many other countries. But I got to meet, as you said, the teams in person, their constraints, their challenges, the way they worked culturally was different.
It was the
Um,
best part of the job as far as I was concerned.
I'm going to say the same thing to you. And then you also, and then I was working with America long before. I mean, I hadn't been on a plane before, Mike, and I was working with people from overseas, and then I got to travel a lot with my workplace. But this pandemic has stifled that travel, has stifled a lot of the airplane movement, and I'm wondering, with that disconnection now, perhaps. How does that change group dynamics? What are you seeing, just from your armchair observer's view, and also the distance from the customers who may be in Europe, for example, when you're working on a chip in America? What happens
Well,
there?
I do have concerns because, if you know somebody, like you and I know each other, we can have a conversation like this over Zoom. It's natural because we have that interaction already established. If it's a customer you haven't met, it's not as natural. You really have to work at it. Also, when we would go on the road trips to meet with customers, being in the room, being able to see not just one person, but be able to read the body language of everybody in the room. Who are the people who are the decision makers? Who are the people who are the junior engineers who aren't saying anything? We're going to miss out on that if people can't travel. And I think it's important that in any type of business relationship, once in a while, you actually get to come together physically. I think that's important. Maybe not as much as we used to, but I think being able to establish those relationships is important. And I know certainly with the engineers, like I told you when we were bringing engineers over from India, we didn't just bring them over and train them. We became friends. We were taking them hiking. I would take engineers from different countries to the local rodeos. Anything that we could think of to try to make it an enriching experience for them. So we became very close, and there's value in that. And I am afraid we'll lose that.
Yes, they were among my most precious moments myself. And what happens is a process of reciprocity. When you would travel and I would travel, how many times was the red carpet rolled out and you'd do things that you'd never have done on your own? The memories, I go back to, it was only for me a 6-year period, but it was so rich. We had 150 engagements during that time. Let's call them projects,
Yeah.
and RFIs and RFPs and RFQs. And I look back at that period of the photos, and back then you didn't have digital cameras, so we didn't take that many photos, right? But
Yeah.
crazy places in China, inverted commas crazy, like they're not really crazy. It
But they're
was,
different from our cultural experience.
yeah, completely. And so we worked a lot with Bharti and Reliance in India, so we had a lot of their staff come to Wollongong, which is a regional place in Australia, which
Mhm.
they wouldn't have come to if they didn't set up shop with us. And so one thing that we're stressing in the co-design approach, that philosophy I'm talking about, where you're dealing with public interest and big scale things that affect all citizenry, how do we get closer to users? How do we respect stakeholders? How do we do what you said, which is who are the key decision makers around this table? And in our case, how do we even get these people to sit around the table together? Because often there's these conflicting interests in our bigger scale societal projects. And the money, where's that going to come from, is a little bit more complex when we're dealing with the public interest. Because in private corporations like yourself and myself in the past, we knew where the money was going to come from, the customer. But in this case, are we going to ask citizenry to cough up money? the homeless, but we're doing projects for the homeless and with the homeless.
Yeah.
Surely they're not going to pay for the project. And so now we're looking at how government will fund some of these initiatives at scale. But we're learning a lot from your first-hand experience of a large-scale company. Like, give us an idea of how big the company was at its height.
I want to say at one point, Motorola, when it was still Motorola, was 120,000 people, if I recall. I have no idea how big NXP was when I was there, or even now. It's also a large company. It's interesting though to see those corporate entities changing and evolving over time. So the Motorola that I hired into doesn't exist anymore. It fractured. It went into a dozen different pieces, each of which got bought up by somebody different. And that's an interesting experience too, just to see how the cultures split and come back together. One of the things I saw that was kind of surprising actually when Motorola merged with NXP is they had a very similar culture. That was a very easy transition for a lot of us because they weren't that different from our culture. Whereas some other companies that we looked at were very different. At one point, we had looked at potentially merging with Qualcomm. That was not going to be an easy merger. Now, eventually, it didn't happen for regulatory reasons, but we got far enough along with the due diligence to realize that from a cultural perspective, there were going to be some very big compromises that we would have to make. So, I think that same kind of thing will probably apply even in the types of projects that you're talking about, where you've got different players with different end goals, ways of doing businesses, and restrictions that they have to live under. And sometimes those are simply not compatible.
And this notion of an imperative or a driving force or a motivation or vested interests. How do you get community groups who are loggerheads coming together and having dialogue is going to be one of the things that we're investigating through this. And to try and achieve multiple aims as defined by the users, because that has to be done in an equitable way. And for example, if we're doing something in Phoenix or Maricopa County in Arizona, the question will be, well, how many people do you need to have giving input? When we say with users, are we going to door knock on every single household in Maricopa County? Are we going to send out a survey and then how many are coming back? Not many. How do we feel the vibe and sense the vibe? And that's where a lot of the work on smart cities that ASU is doing may well be a contributing factor of sensing what's actually happening and getting indirect feedback from data collection.
Yeah, I mean, especially in America right now, if you look at it, we are not one America. It's a very divisive time in our history, not just politically, but economically, socially. There are lots of different groups that you're going to have to deal with.
Highly complex environment and forever changing. I think at the moment, it used to be very polarized and we sort of knew there were two camps, and now there are all these other camps that are rising. I'm predicting some of the rising and the falling happening quite quickly with these groups. But again, you've just alluded to the idea that political orientation is going to be very important in areas of this group, which are about social justice and environmental justice and technology access and transparency and so forth. One thing I wanted to allude to was the size of the company. At its height, Nortel was also 130,000 employees in about 150 countries. And I just want people to think about that, our students to think about that. We're talking 130,000 employees. And if you look at companies the size of Google right now, they're not 130,000. We might think they're everywhere, but they're not. If you look up from memory, they're 107,000. It's only Amazon that's got this like huge figure, like 600,000 plus, because they're moving things, right? They're
The physical
physical,
infrastructure.
right? So this gig economy has given birth to agility in technology deployment. So has cloud computing. So has all of this other remote, remote deployment of networks. For example, who would have thought that was possible? That an engineer could sit from home and it's all software based, and voila, you've got a new network going.
Yeah.
But the size of our corporations were huge. Um, and I just want students to think about that, because what has meant this shrinking of this large scale sort of outfit to what commensurately and relatively is going on today is time sensitive. And I want you to comment on this sort of these gate processes that used to be sort of a little bit ill-defined and wishy-washy, and sort of we knew what they were in, loosely, and how processes have intensified. They've become very rigid, perhaps, in terms of what's done at each stage, what's collected, this mechanization aspect of that, this quantification, but also what's the typical length of a project? And I know that it varies in your business of ICs, but can you make a comment on size of the workforce, what we're expected to do today as opposed to in the past, and time? What's an average sort of time that we dedicate to a project?
I used to think of two different types of projects when I was doing system design. I would have something I would call a derivative project. A derivative project would take an existing product and make a tweak on it. Just a few changes, but something that could be done relatively quickly. And I would usually figure that would be something that I could turn out in a 3 to 6 month kind of period. Because I'm starting with a well-established design base. Whereas a new product, I was looking typically 12 to 18 months, sometimes 2 years. Now, when it got to be 2 years, that was considered bad. So that's the point at which you have managers haunting you, making your life miserable because you're now on the third or fourth pass on the design because you didn't get it right the first time. But a year for a new product development in the IC business is not unusual. Now, it will be different for different businesses. So if somebody's developing something that's a new printed circuit board, well, a PCB can be designed very quickly, and it can be designed and built in a matter of a few weeks. But then getting it to actual market with everything else that goes with it, that's going to add on to it. So it will vary from business to business. Also from a complexity perspective, again, you and I have talked, some of those early designs I did, the smallest one I ever did was 12 transistors, back in 1980, 81. Whereas today you're talking millions and billions of transistors on some of the types of things that Intel does. So, it's been many orders of magnitude governed by Moore's law. And that's really what has driven the semiconductor businesses, because they had to build in reductions in cost on a regular basis according to that. Now that's starting to fall away. At some point, Moore's law is no longer achievable, but people keep trying. So, it's a treadmill. It always is.
I recently hosted East House 20, and there is a theory, actually, the treadmill of production, TTP, as noted by one of the authors and presented. So the treadmill of production actually exists as a theory, which I hadn't come across.
I did not know that.
Well, I used to know about the treadmill process because you see it, but here is an interesting thought. So you've got our engineers and developing new software systems, new simulation processes, new ways of doing and being and discovering. And so we're getting better and better at this. And once I remember one of our employees, he was a top mathematician. He actually worked for Silverbrook Research, that is a semiconductor company in Australia, when he left Nortel. And we used to joke that we would make ourselves obsolete by the things that the software we created, right? So we used to challenge each other. How can we do away with our jobs? Like, so automation was right in our heads. Is there a way that in the future, even the planning process could be automated, right?
Oh yeah.
And the amazing thing is that as we get on this treadmill of production, the more we get better at building these semiconductor chips from like 12 transistors to like billions, and then prices fluctuating, because just because we're doing billions, it doesn't mean we can charge billions of dollars more, right?
No, you're usually charging less.
So this is crazy. That is there a point in the development of a system or systems, whatever we're dealing with in our lives, that we go, you know, anything more than this, we're gonna, we're gonna wipe our. What's your thoughts?
We might be edging up on it, but if so, it's taken my lifetime to get there. I mean, you think about the laptop that you're using or that I have here, compared to what I was using 20, 30 years ago, it's amazing. My phone has more processing power than what we were using to design ICs back in the 90s. It's always stretching the boundary. You've always got gamers who are demanding more. But on the other hand, as we are hitting some of the limits of Moore's law, they'll have to pay more for it. See, up until now, we've been able to give more for less. When I left, retired a little over a year ago, we were down to the point where, a microcontroller or a sensor with a MEMS in it could be bought for less than $1. That's amazing to me, that the amount of engineering that would go into these products, and we're talking millions of dollars, but when it's amateurized over millions of devices, you get them super cheap still.
I'm really thinking about that. Thinking about the role of IoT, for example. The fact that for networks, very similar, right? The networking business. I know early on, people used to talk about, have we over-dimensioned, the submarine cables, the access points, and actually what we're finding at the moment, especially during the pandemic, because we used to do the teletraffic engineering for the busy hour of traffic. Well, that busy hour traffic profile has changed dramatically now.
Oh yeah.
And no one was ready for that. Even the people like Australia that were banking on a national broadband network scheme, fiber to the curb or fiber to their home, and it really wasn't truly fiber to the home. They should have gone that way. But they're in trouble. There's times I'm at home, I don't have a proper stable connection, which doesn't make sense. But it is because of this changing busy hour of traffic.
But when you think about it, though, I mean, I remember when we were designing digital signal controllers for the voice over IP market. And honestly, I was a doubter back then, because at that point in time, my internet connection was so bad, I could not imagine that I would ever want to do voice over IP. It just didn't seem feasible to me. And look at what we're doing right now. It's amazing. To me, it's a miracle that we're able to do this and to make this transition in one lifetime.
I think so too. John Roth, who was the CEO of Nortel in the 2000s, early 2000s, I remember a letter that came to every employee, all of us, in different languages. He called it the right angle turn, because at the time we were banking our bets on ATM, the asynchronous transfer mode, as being the protocol that we would all navigate to, away from the old X25 and other kinds of network bases. And what we ended up with was this IP-based system, which was like a public thing, which shocked us. We all had to go through IP-based training and understand voice over data and multimedia over data and everything else over data. But with the transistors now and the chips, I think what we're seeing is a hope, perhaps, for the transistor industry anyway, that these transistors proliferate even more in everyday objects. They become different form factors, more flexible electronics, perhaps.
Actually, you make a really good point there, because when I was a kid building designs, electronic kits, it was at the transistor level. Now I'm still a tinkerer today. So when I tinker today, what do I use? I use a Raspberry Pi, which can communicate with the rest of the system over IP. I'm doing Ethernet programming at home for fun. Now, the world has changed. But what's happened is we've gone up through the level of abstraction over time. And each of these systems we've used to build larger systems, and we use them as easily understood building blocks. And we've got the software libraries that go with each of those hardware components so that we can build things up and it becomes a reasonable thing to approach. So that hierarchical manner of raising that abstraction level, that's what we're taking advantage of now. You know, when people design a new system, they're not going away and implementing their own TCP/IP stack. They're using one that comes from the manufacturer for that particular chip. They pull it in as a library.
I know we've explored so many things during this conversation, and perhaps
we've probably gone off track, but
not at all, not at all. I think the students, many of whom are very technical in this particular cohort coming through this session, will love this. I'm positive, and they'll compare notes with what they're doing internally in their own organizations, whether it's armed forces, other private industry, or public places like universities where they have roles as CIOs. So I want to talk about the importance of project management as a last point.
okay.
And you're talking about this rigidity, you know, this gate process. How important is it to plan? What kinds of systems did you use to help your project management and to reach those things? And did you have project managers in your
We definitely did, and that probably is one of the toughest jobs, especially for the large systems, or in my case, the small systems. But you know, they're very complex. There are lots of different disciplines involved, and so what we would tend to do over the last, let's say, 5 or 10 years, we would have essentially a role within the organization where there are a number of people, that's their job. They're program managers. And there's a natural tension between a program manager who's trying to put together a schedule and a cost budget to meet management's demands versus what the engineering teams think they can actually do. That can be very interesting, and it can be very frustrating for all concerned. Typically, you know, you need to design a system. You need to put together a project plan that's fairly detailed. All of the things that we talked about, the minutia that's involved. If any one thing is forgotten, you screw things up. The product's not going to go to market. So you do have to plan this stuff out ahead of time. That's where the project planner can help tremendously. But they need the technologist to help make sure they've got all of the right items in the project plan, and that they're feasible, that they butt up when they should butt up, or that they overlap when they should overlap. You know, all of those types of considerations. It's a very back and forth type of discussion, and it is painful because there are so many different players with different perspectives that have to be satisfied. So yeah.
I used to have a wonderful manager, Jean-Luc Thibault, who was French-Canadian. And Jean-Luc would always say to me, Katina, 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 in his French accent, you just have to think about the project plan and then multiply it by 2.5. And he was often right.
Mm-hmm.
But yeah, increasingly, particularly while I was working in consulting, I worked for a short time with Anderson Consulting, and very rigid, you know, around the mid-90s in terms of project plan, because you're on the customer site, you're billing the customer. And I remember once, because I was so young and innocent, I think I was like 19 or 20, we were working on a Ampol Caltex merger in Australia and using or implementing the SAP R3 system. And I remember putting in a job sheet which had the real number of hours that I had worked, which were astronomical as a young person, just to wrap my head around it. I think I put in like 55 or 60 hours that week. And he returns it back to me and he says, let's go and have a chat. He said, you do know the client sees your job sheets? I said, yes. He goes, you do know you were only allocated 35 hours this week? Oh, but I worked, you know, close to 55 to 60. Well, sorry, you know, we've only charged them this much for this week for the persons who are on this. that was a reality check, Mike, because it was the first time I didn't feel like I was lying, right? But it was the first time that it went ka-ching. Everything I'm doing is linked to a cost, and someone has to pay for that. And the project planner may have underestimated or overestimated, or bad luck. That's just what it is this week. Um, so I find that very interesting from a manufacturer's perspective, different to the consultants. But good project managers are very well sought after. So who knows? There might be some of those people in this cohort who are really good at being people, bringing people together on a journey, because the product development process is a journey.
Very, very much so. Yeah, another point that kind of layers on top of what you just said, and that is, I think it's really important for all members of the team to take into account the fact that they are a cost-based resource. You need to justify your existence on a continuing basis. I've known a number of engineers over time, good engineers, who like doing one thing really well. That's a very dangerous thing, at least in my perspective. I've always been a generalist. Now, the downside on that is many organizations want specialists. They want engineers who do one thing and one thing only. The risk then is, if that one thing becomes something that they don't need, you are now redundant. So you're always going to be trying to balance the fact that you've got to justify your experience, your hours, your life in terms of what you're doing today, but also being flexible enough to move laterally in the future.
Well, Mike Stanley, it's been a joy to talk to you over the past hour and a bit. You've not
Always.
only shared, I don't know, I'm not actually counting the time. I wouldn't know how long we're talking for. I'm just happy that we got this amazing opportunity to pick your brains and learn from you. We've learned just to go over things about manufacturing processes. We've learned about going from sort of a concept, a problem definition stage, right through to the end of, the designing, the prototyping, the testing and refinement, the evaluation, this notion of gates, plans of records, all the different skill sets that are required to go into sort of a project, virtual teams, evidence in our ability to talk about data sheets or deep specifications, things that have changed in teams over time, the way technology has changed, even within your own workplace, both as something that you use it as a tool and also as an outcome of a product.
That's right.
The idea of time, the idea of roles and gates and so forth. And I just want to say thank you so much, because students also learnt about skill sets and strategies as employees in companies. They've got their own journey to fulfill. And we've got all of that from you in the last hour. I just want to say thank you very much.
Oh, it's my pleasure.
Thank you. And I hope when we are out of the pandemic, you might get to visit us in person at ASU and have the School for the Future of Innovation in Society listen to you live.
I look forward to it.
Thank you.
Okay.
Thank you.
Thanks, Katina.
Thank you, Mike.